we're going to use fundamental trig properties to evaluate trig functions and rewrite certain functions in terms of, like, for example, tangent, we're going to rewrite that in terms of sine in particular quadrants. Okay, so we've got several really important fundamental properties. We've got the reciprocal properties and we've got the Pythagorean properties. So the reciprocal properties we've talked about a little bit, where sine and cosecant are reciprocals. And then we've got our secant and cosine and tangent and cotangent. Okay, so those are the reciprocals, and then we can always write tangent as sine over cosine and cotangent as cosine over sine, just because of the definitions there. Sine is y and cosine is x, and so instead of writing tangent as its definition, y over x, we can write it as sine over cosine. And same thing here, cotangent is x over y, but because of how cosine and sine are defined, x over y can be replaced with cosine over sine. So those are the reciprocal. Now, we also know that on the unit circle, x squared plus y squared equals 1 because of that radius of 1, and it's centered at 0, 0. So replacing x with cosine and squaring that, and replacing y with sine and squaring that, we could get the Pythagorean identity. And instead of always having to write those parentheses, we just write that cosine squared of x and sine squared of x is equal to 1. Okay, so that's a really important, we're going to use that all the time, that Pythagorean identity. And then we can divide, if we wanted to, we can rewrite that. You could divide everything by cosine squared, cosine squared, cosine squared, and you can see sine squared over cosine squared, that's how we get tangent. Cosine squared over cosine squared, that's how we get 1. So if you wanted a equation in terms of, or expression in terms of secant squared, you could use that Pythagorean identity and rewrite it. Same way to get our cosecant, we could just divide here by sine squared. And that's how you get this other one. Okay, so let me show you an example of using this. Okay, my problem is I need to have an expression for tangent only in terms of sine, and we're just looking at quadrant 3. Okay, so just as a little reminder, okay, we're only looking for an expression where this is true in quadrant 3. Okay, well, so I know that tangent is the same thing as sine over cosine. So I'm close, but I have this cosine, and I'm supposed to have an expression that only has sine. Okay, well, I know my Pythagorean identity, so if I want to just not have, I could use substitution. If I could get an expression where cosine of t, I could rewrite that only in terms of sine. Well, I'm really close, because right here, if I subtracted sine squared from both sides, I would get 1 minus sine squared of t. And then I could take the square root on both sides. But we do need to take both the positive and negative square root. Yeah? And then we go back and we think, okay, quadrant 3, this is an expression for cosine, and cosine has to do with the x's. So where are the x's in quadrant 3? What sign is x back in here? Negative, yeah? Right, because I have to go back to the left to get to quadrant 3, so my x's need to be negative. Okay, so just be really careful there. Think about what quadrant's given, and give the appropriate sign. Now I'm going to just substitute, right? I have an expression for cosine, so I'm going to plug that right in. sine of t. I'm going to replace cosine t with the negative square root of 1 minus sine square of t. And my mission is accomplished. I've rewritten tangent in terms of only sine. Done. Okay, let's do this next one. Here I need to find all the values of the trig function. So that's our big goal in section 5.2. It's all about finding the values of trig functions. And these are little puzzles. We're trying to figure this out. We have two hints. We're given the value of secant, and the value of secant is positive. Here the sign is negative. Okay, so we've got a negative sign, so we're down in quadrant 3 or 4. Okay, but when the sign, let's see, the secant is positive, because secant is 1 over cosine. So it's positive when the x values are positive, because cosine is related to the x values. Okay, so that means that to have both of those happen at the same time, we need to be in quadrant 4. Okay, and then we're going to use, again, this fact that 1 over cosine is our secant. And so since secant is 5 over 2, that means that 1 over cosine is 5 over 2. And then just setting cross products equal and solving there, we would get cosine of t is 2/5. So we're supposed to get all of the trig functions. All right, we got one of them. We were given secant. Okay, so moving along, we need to get our sine, and we can use that sine squared t plus cosine squared of t is equal to 1, and then plugging in our 2/5 for cosine. Oh, that's 1 squared. Okay, and then solving for sine squared there. We would have 1 minus 4/25, and then taking the square root of both sides, but remembering that sine is negative, so we're going to use this negative square root. So that gives us that the sine of t is equal to the negative square root of, that ends up being square root of 21 over square root of 25, which just simplifies down to 5. All right, so we're good to go on that one. Now we need to get our cosecant. And since cosecant is 1 over sine, it's just the reciprocal, so the cosecant here would just be 5 over negative. And then rationalizing the denominator there, we would get negative 5 root 21 over 21. So there's our cosecant. And we're almost done. We just need tangent and cotangent. So tangent is sine over cosine. So that would be negative square root of 21 over 5 divided by 2/5. And we'll just multiply by the reciprocal there instead of dividing by our fraction. And so all right, so then that gives us that tangent is negative square root of 21 over 2, because our 5s will just cancel there. Okay, so that is our tangent. We're almost done. We just need cotangent, and it'll be the reciprocal there of our tangent. Okay, so cotangent would be 2 over negative square root of 21, and we'll just rationalize the denominator there. And so we will get negative 2 root 2 all over 21 for cotangent. Rationalize the denominator. Okay, I'm going to give you some time to think about this and work on this yourself. So go ahead and pause and work on number 1. All right, so go ahead and pause. Okay, I want you to always be thinking, where am I on the circle? Okay, quadrant 2, we're back here. Okay, and then my first hint, if you haven't figured it out already, is using Pythagorean identity is the way to start here. All right, so if you haven't figured it out, keep working, use that Pythagorean identity. Sine squared plus cosine squared equals 1. Okay, so using that Pythagorean identity, you can subtract sine squared from both sides and then take the positive negative square root, but just be cognizant we're in quadrant 2, and since cosine is defined by the x values are negative in quadrant 2, and so we need to have this negative. Okay, good. So now work on number 2. Again, just pause. You're trying to figure out where in the circle you are based on these 2 clues. Cosine of t is positive and tangent is negative. All right, and now you're going to find all the trig values. Okay, go ahead and pause. Work on it on your own. Okay, first thing is we're thinking about where on the circle we are based on those 2 hints. Okay, so hopefully you have looked at where cosine's positive and tangent's negative, and that only happens in quadrant 4. Okay, so we're in quadrant 4, and now we need to find all of the trig values. Okay, if you haven't worked on this yet, go ahead and pause again and start working on it. My hint is to start with secant first. All right, so pause and then start up when you've tried it.